Friday. Missed all y'all. Don't say that. Anyway, today we're going to jump into the algebra half of the course. And so we're going to start with a review of something that is kind of grade 9 content. Tomorrow we'll jump into the review of what is grade 10 content. And then beyond that, we'll move into what is the grade 11 content. Does that make sense? Obviously, algebra is for some people like natural, and they like that part of the course. They like when they can kind of just get and plug the numbers in. And other people, that's the part of the course they struggle with. What I'd ask, come grab, has anyone, hands up if you've used Algebra Tiles before for modeling? The which? Okay, I appreciate your candor, but I'd like everyone to come up, and you don't need to get one set each necessarily. You get one at least for you and the person next to you. Does that make sense? I don't care if you learn how to model these things with Algebra Tiles. I'm going to show it to you that way first. Then the second way I'm going to show you is just purely algebraic. And the third way I'm going to show you is sort of with the trend we see. So again, come on up. I'd like at least every pair of people to have a set of tiles.
Did you say she just?
Yes, they have more little.
But there is one on top.
Gentlemen, do you guys have a set? Yeah, perfect. Tim, come grab a set, please. Okay. There, in my mind, are two kinds of basic thinkers when it comes to algebra. There are people who find visual techniques like this helpful, and then there's people who find them confusing. I happen to find the algebra tiles more confusing than helpful. It does not help me. Some people, it really, really, really does help. So I'm going to teach how we use the tiles to model this. If that works for you, you'll always have them. You'll have them on the test, you'll have them on the exam, they're there. And if it helps you, it can help you tremendously. So it's always there for you. If, like me, you find them more challenging than useful, that's fine. Once we're done with them today, you never have to use them again. I'm never going to insist on your using them, but you may find them useful. Does that make sense? Okay. So we have learned 3 basic forms in which we can put a parabola. What are they? Standard, factored, and vertex. Fantastic. Isn't he good? In time, he could be great. Yes, sir. Yeah, sure. So what we're going to deal with over the next bunch of days is how we can get a parabola given to us in one form. I'm not doing that. I find it very distracting. Thank you. How we can get a parabola given to us in one form and convert it to another form to get the useful information from that. So with that in mind, today we're going to look at specifically going from factored form to expanded form. You can even write that on the top if you want. Today we're going to go from factored form to expanded form. And to do that, we have to learn some algebraic skills. Specifically, we have to use something called the distributive property, which should be familiar to you. Really quickly, if I had 3 times 2 plus 1, and now I know I could do 2 plus 1 is 3, and do 3 times 3 is 9. But the other way we could show this is using the distributive property. What am I hearing? A which? Jeez, that's loud. Okay.
Doing stupid stuff.
Not like us. That's important, but not for right now. We're going to talk about that next unit. Our whole last unit's all about money. That's the goodie. Sorry? Nope. Good question, though. And hopefully you've learned that instead of doing the brackets first, I could distribute this and say that this is the same thing as saying 3 times 2, which is what? If you learn FOIL, I don't use the expression FOIL because I don't understand it. I draw arrows. So we could say 3 times 2 is 6, and 3 times 1 is 3, and the sign between them is addition. So this equals 6 plus 3, which is 9. Is that the same answer as if we just do the brackets and then multiply? Yeah. Now, obviously, we're not going to use this to solve a question like that. We don't need to. We can just plug it into our calculator. But we're going to use that same principle here. So this property is called the distributive property, where if you have multiplication outside of a bracket, number by everything inside the bracket, all of the terms. And I want to look at that when we have unknown values involved. So here we have x plus 2 times x plus 1. And to do that, we're going to use the algebra tiles. And if you hate algebra tiles, I'm sorry. Have you not?
Remember that game we played in conference class?
Yeah.
Factress?
That was a good game.
Yeah.
I liked that.
I'm glad to hear you say that, because guess what you're going to be doing in a little bit.
Playing Factress.
Not today, though, but in a couple of days. It's like Tetris, but for factoring.
Factor it before it's bottom. I got so good at it.
Good. Well, that's basically what we're talking about here. So, in fact, you're going to see me. This will look familiar to you, probably. Well, so what is the question I gave you here? X plus 2 times x plus 1?
Yeah.
Okay. So I want to talk about how we use the algebra tiles to model things. The basic idea is this. This blue tile represents just one number. By the way, if I wanted to represent the number 3, what would I need? 3 of those. Does that make sense? What is the red single tile then? Very good. It is -1. Oh, let me check. Oh, you're totally right. Ah, God, see, I do this every time. Do you know why? In financial books, red is always negative. So if you're talking about, have you ever heard the expression like into the red or in the red?
Yeah.
Yeah, if you are doing workbooks, like if you keep track of money, you use red ink for negative values. So this is counterintuitive. Sorry about that. So red is +1, thank you, and blue is -1. What about this long line here? Yeah, this represents just the unknown x. What then would we expect the blue one to be? X, but if red is positive x, blue will be -x. Good. I'm so glad you mentioned that, and I didn't get all the way through this note using the wrong colors. That really would have been embarrassing. That would have been awkward. It only matters specifically because I'm going to use a piece of software in a minute to show you, and then it would have been the exact opposite of what I showed you. Okay, so now when we look at this, how could I show x plus 2? Using the tiles, how could I model x plus 2? What would that look like? Okay, so a red bar is the x, and the 2 red squares each represent 1, so that's x plus 2. Good. What about, what's the other one? X plus 1? Okay, how would I model that? Very good. So the same thing, but this time we're going to use just 1 square, like that. And what I want to show you is that if you use the tiles, you can show how we would multiply these graphically, visually. Again, if we do this and you go, that doesn't mean anything to me, that's fine. But what I want you to do is set those 2 values up like this on your board. So put x plus 2 along one side, x plus 1 along the other side. It makes no difference which side you do with. Yeah, and if you look on this thing, you can see it's got like the edges here. Set it up on the edges. So again, yeah, you're great. So on the edges, right? Great. Have you done this before? Have you done this before?
Yeah, sort of.
Cool. Fantastic.
I know what I'm doing.
Yeah, so this particular one, we have, both of them have an x. This one here has x plus 1. This one here is x plus 2. So a long bar and a single, and a long bar and 2. Again, this has made the one on the top and the other on the side. Just so you know, before you take it away, what would that have been? This is x plus 2, but what would that have been with it in there? Not x plus 2, but... Well, still plus 2, but how many x's do you have? So it would be
2x plus 2.
good. That wouldn't have been wrong. That's a thing. It's just not what we're doing right now. Okay, so now we multiply this out. We multiply this out by filling the squares. So when we have a long bar times a long bar, what shape will that make in this space? It'll make a square. Does that make sense? If we do x long by x wide, we get an x square, which is those ones. So you can fill that in. Now, what about when we do this long bar by just a single thing like that? What do I need then to fill this space? Yeah, just a bar, right? Does that make sense? If we do a long one multiplied by just a single, that fills that space. It is confusing at first. You may find it helpful once you get going. And then what fills the space? Yeah. So now, what should I do to keep going here? What am I going to need down here to fill this in?
2 bars and then 2 little small ones.
So 2 bars, and they go here and here like that. And then what else do I need? Great, and where do they go? In the space in the corner. Hi, it said I liked it. Does that make sense to everybody? Can I walk you through it again? Okay. So I'm going to draw this on here, and I encourage you to maybe draw one on as well, just so you have a copy in your notes of how you did this. But on the top, we're going to put x. Which one did I put on the top? I can't remember. Plus 1? Plus 2.
No.
Was it 1?
Plus 1 was on this
It doesn't
way,
matter.
and then plus 2 was this way.
Yeah, it doesn't really matter, but just so it looks like what we did. This, I'm doing my best.
Are you?
Yes.
Are you really?
God, you guys are so negative. Okay, there we go. So now, to fill the space, here I'm going to have a shape that is this long and this high. Does that make sense?
Why is one of your larger than the other?
Because I don't like you.
Maybe the different.
It makes sense when you think about it.
I like my.
See? Yeah, he's smart. And so these come together and make, as you can see, a perfect square. Just like I've drawn it.
Yes.
A perfect square.
Not a rectangle.
Not a rectangle, and there's no curve to it either.
No.
It's a perfect square.
That's your eyes.
We could take a ruler to that.
Yeah, no, listen.
Perfect.
If that doesn't look like a perfect square to you, I think you have some sort of nerve damage, and you should see a doctor, because it's a perfect square. But what about when we do this tall one here by this little guy? Well, now it's going to be this tall, but it's only going to be 1 wide. Does that make sense? And so what fits here is just one of the long squares.
Excuse me, interruption.
Yes.
Hello.
Yep.
Hi, is Chelsea Wallington in class?
She is, yeah.
Chelsea, come to the office, please.
Yeah, she's on her way. Now in this space, what do I need? Well, it's going to be this long, but it's only going to be 1 tall. So a bar fits there. This next space is going to be this long, but it's only 1 tall. So a bar fits there. And then here, it's 1 by 1 and 1 by 1. Okay. Now when it comes time to actually answer the question, and say, what does this equal? We can just look at what each of these values equals. This shape here is what shape? It's perfect again, I remind you. Yeah, this is an x, and it's squared. This bar is, how big is this bar? I'm going to change my color here so we can see. This bar right here is just x, right? Will that help? That might help. Yeah, what about this bar down here? It is x as well. What about this bar down here? X as well. What about this cube here? Is it x?
X squared.
It's just 1.
Oh.
And this one here?
Oh,
Even.
that looks so good.
And all together, what do we have? All together, we have 1x squared. How many x's? 3 x's. And how many singles? 2. And all of these are put together. Now, do I have to say 1x squared? No, it's not wrong if I do, but it's considered kind of poor form. We typically just say x squared. I wouldn't mark you wrong if you said 1x squared. Yep, if we had 2 of them, we'd say 2x squared. And we will get to some examples like that. That's what we're going to do at the end. And again, for me, I find this more confusing than helpful. But you have to believe me that some people, and I've seen it, some people who you try to teach them algebra for weeks and weeks and they can't get it, you give them these and they just go, oh, I get it. Yeah, so like everyone learns differently, and there's nothing wrong with that. Like if you have a visual mind and you like to see things as shapes, this can be really powerful. I want you to try the next one. All right, so try this next one. Yeah, I should say, if anyone wants markers so they can draw these in your notes, so you have in the notes how to do it, it's not a bad idea.
The day I leave my pencil case and I don't have to.
Oh, look how covered.
What colors do you want?
She's good.
Tiles are the greatest thing ever.
I know, right? That's it. And it just depends on how your brain is wired. When Mr. Calford first showed me the tiles, I was like, I'm confused. I don't think that's helpful. And he said, just trust me, try it with your students. Some will feel like you, and some will go like, oh, I get it. And it's so true.
Like I don't understand with the arrows and okay.
Yeah, exactly.
I would much rather do that way.
No.
That's okay.
I like
And you know what you're going to do by the end of this note?
I'm a hands-on learner.
Yeah.
I need to
That's it.
feel like I need to know.
I think I did.
You did beautifully, I think. The only thing I don't like is you did x plus 3, and that should be a 2. Yep. But try this one out. See if you can model it. What about me?
Just some vodka.
Some what?
Vodka.
Vodka?
Orange juice?
I have never. So here's the deal. I'm not a big drinker, but I'll tell you what I don't understand. Vodka.
It's so good.
But it's not.
Yes, it is.
So here's the deal. I don't care how much.
I never need.
I don't care how much you like drinking. Alcohol doesn't taste good.
No.
The things you put. No, of course it doesn't. It tastes like it tastes like a combination of nothing and burning. So we add it to things that like we like the taste of, right? Like
But then that
be it like juices or things like that, or in the case like I love Scotch whiskey. Like the Scotch has all these interesting notes from the process by which it's made, right? Alcohol doesn't taste good. So then people who drink vodka, to me that's like, yeah, I've just never understood it. Like I like a glass of wine, I like beer, I like a whiskey. I've never, and like, I guess if you mix vodka with like lots of juice, it tastes like juice that only mildly tastes bad. And that's all right, but I've never understood it.
if you have enough, then you don't taste it.
Why?
I think that's a dangerous way to approach it. I think this is not, that sentence right there is why we encourage adults to drink and not children. Like really, in one sentence, you've summed it all up. Go big or go home.
When my mom started.
That's what I said to the, that's what I said to the doctor after he pumped my stomach. Like, come on. I don't get it.
I don't understand these things, but I understand.
I know, but just because you're
I don't
clever.
get it.
Okay, so I want you to try. So to do x, what is an x? Of these, which one do we call x? Good. So put up here, x, and then plus 3. So show me plus 3.
Yeah.
That is
No,
Okay. Guys, can I see this? Can we model that out?
It's actually so good.
Nice job, Tim. Now, where this meets this, what's going to fill that?
This thing.
Great. Good. Keep going. Where this small one meets that long one, what do we get? Good.
What is my mark in this class?
We can look it up after if you want.
Yeah, when do your reports start to go out?
Like last Thursday. It should be at your home.
I don't have it yet.
Oh. Oh, I think.
Love it. Love it. Beautiful. Good work.
Go back to your old slide. Did you get my?
No, we know the people that
I
are
have to do that a couple times. It's quite awkward.
That would be awkward. We always get the mail from our last owner, and he's dead, and that's awkward.
Was it like health insurance or something?
Yeah, it's kind of sad. So I send it. Yeah, they're supposed to get some, so. Anyway, okay.
Have you ever?
You don't have to draw it.
Email just like, what is he getting?
I think that's illegal.
It is.
He's
I don't think you're allowed to.
No,
I mean, he's not going to sue me. No, we know his family, so we just send it on to them.
Do you think they open it? Because technically, wouldn't it be illegal if they're opening it?
They would have been his executors of estate, so they can open it.
What is he still getting though? Is there like something?
Like most of it is just like if it's like from like a newspaper or something, we throw it out. But if it's something from the government of Canada, we send it on.
I
Or
bet
something
you
like
it's
that.
Probably like he bought a new car or something, so he's gonna pay that off. So the family has
Yeah,
to do it.
exactly. Okay, so how would I model this? What am I going to put? It doesn't know which we do on top, on the side, but what do I put here?
2 long sticks.
Like this?
No. 1.
Oh, one going up, one going sideways?
Yeah.
Comme ça?
Yeah.
Oui, c'est bon.
I need a lot of little guys.
And then on one of them, put 2 little small.
Like that? And down
And
here?
the other side you can see.
Perfect. Okay, and when I do that, what does this model out to give us?
Square.
So the 2 big ones, it's going to be this long and this tall. We get a shape that looks like this. A perfect square.
And then, can't you just like tap it and like choose red and it'll be gone?
I think there is a way to do that, but I'm not that clever. Okay, down here with these 3 singles and the length, what do we get?
3 long red.
Good, good, and good. What about these 2 singles with that length?
2.
Like that? Do you know the newer Surface Pros have exactly that? Where if you rotate the pen, the cursor rotates.
6 small things.
I'm not made of money right now to update my computer, but I work for the government. Listen, don't get me wrong. I get paid very well for what I do.
Not full enough.
But when you're an adult, you have all these other expenses that start cropping up. I miss being your age because even though I obviously make a lot more money now, I had a lot more money then to spend. I could spend on whatever I want.
That wants to get a sword.
A what?
A sword.
A sword?
From The Walking Dead.
Am I the type of person who wants to get a sword from The Walking Dead?
Yeah.
No.
No.
No, I haven't seen The Walking Dead yet, so maybe once I've seen it. But
The back would be.
so I don't have a lot of time. So I love Breaking Bad, so I watch Better Call Saul now, which I really like.
I watched 3 seasons of Breaking Bad in 1 week.
Oh, I love it. Yeah, it's so good. I've enjoyed Stranger Things, and Stranger Things 2 was excellent also. Have you guys seen Stranger Things?
Not yet.
Okay, so Stranger Things,
I haven't watched the second.
in my entire career working, I've taken 1 sick day, and it was last year, where I just couldn't drag myself into work. I was so sick, and so I put the first episode of Stranger Things on, and I just sat on that couch until the last episode of Stranger Things, and it was very good. Okay, yeah, I do not. But it was fun. I enjoyed binging on TV. I see why people do that. Okay. Same idea. Okay, what do we get here? What is this big red blob here? X squared. This is, of course, x, another one, another one. You make that sound like it isn't the best part of your day. I accept your apology.
You know how we're like, Mr. Orlando, you know.
Yeah, no, it's true. Not yet. Eventually. Okay, all together, what do we have here, Delman? What's this work out to be? X squared? I did. But wow. Plus 1, 2, 3, 4, 5, 6.
Where did I get 5 from?
I don't know.
Oh, you see, I didn't do times.
It's almost like if you'd modeled it out, you wouldn't have made that mistake. Just saying.
You see,
Just saying. Okay. Does this make sense? By the way, you don't ever have to draw these. Like I'm drawing them so that when you guys go to look back at this note, you can see what we did. But using the algebra tiles, you have the model there to work with. Now, it's not a bad idea to draw them.
I don't like the tiles. I like to just do it.
Just write it
Yeah,
out.
sure. Nothing wrong with that. Now, what happens when we have negative numbers? Yeah, we model the negative numbers with blue, remember? So go ahead and model this. The x's note are both positive, but that 2 is negative.
Negative.
Both of the x's are positive, that's right. So we have x and we have x. Yeah.
7 o'clock.
No
Sports class.
Indoor. Don't try.
Everyone should come.
I say this with all due respect, but I'm probably going to be at home. Tonight
Just
at
be
7.
at home.
Actually, I have a funeral to go to.
Yeah,
At 7, so that's so no. Sorry. Sorry. No. Why have I not driven a hearse?
They're Cadillacs.
Because I don't think they just let you like do that.
I'm sure he
Can't
has like
like
5
run though.
Actually, when Neil Young was in his first band, they bought a hearse and they named it Morty, which is pretty funny, and they used it as the tour vehicle because you could load all the equipment in the back, which makes sense, right?
You just have a big.
This is true. Okay, now there's only one thing you have to know here. And this, by the way, this is true in math, but it's also true, like in relationships in life, which is when negative and positive come together, the result is negative in multiplication, right? Yeah, when you put a negative and a positive together, the output is negative. And you've all known this. You have some friend who you think of as this positive influence in your life, and they end up with somebody negative, and the whole thing is just negative, right? That's how it goes. So let me take a look. Yeah, it looks great. Good job. Okay, so let's take a look at this. The big long red one with the big long red one will make one big red, and it'll be a square, right? Comme ça? Did you really? I'll knock you out. With my car. Okay. I don't drive a Prius. So you moved somebody else's car? Now this is getting scary. That's what I went to teachers college for.
Is that all they taught you?
That's all they teach us.
You just sit there for a year, just like with the smart.
I try not to think about teachers college. It was one of the worst experiences of my
And
life.
then, like, when
Like drawing
16 months straight.
Oh, they
I did a master's in education. Now it's all 2 years. But at the time, my master's was 2 years, and we did it in 16 months straight, and it was...
Is teaching just making stuff, and then just like when you mess up, just like damn this calibration.
Here's the yeah. Teachers college, they just teach us to go, stupid smartboard isn't calibrated, stupid and then be like, all right, everyone get your textbook out and do question 7. Orlando's napping. That's it. That's all they teach you. No, you know what? Teachers college should be great, but it isn't. But teaching is great. Teaching is a good job.
Is it really?
I like it. Yeah.
I feel like teaching would be a bad job because all the kids are like, damn it, I gotta go to math with Orlando.
Well, but nobody does that. You guys are all like, yeah, I get to go to math. Woo! All right. So what about this long one here and these 3? What are we going to get? 3 like this?
Well, no, I was asking if that's what you wanted.
You're gonna get 2 long ones.
Yeah, I'm going to get 3 of the x's, right? In other words, x times 1 is just an x, and x times 1 is an x, and x times 1 is an x. Okay, so that's all easy because everything is positive. But what do we do now when we have x times a negative 1? What do we get? Very good. We're going to get negative x. And that's going to look like, whoa, ironically, that went in the right place, but not where I meant it to. So it should look like that. And then what about negative 1 times positive 1? Negative, 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 negative.
Wow. I feel almost like I definitely did this last year.
Did you? I'm sorry.
And I hated it.
I'm sorry. I'm sorry. Okay, all together, what is this? X squared, x, and x. But this down here is negative, and these are all, those are all negative. What, negative?
No, I'm fine. I got it now.
Okay.
Breaking Bad as a class.
No. Good question, though. Okay. Now, all together, what do we have here?
X squared plus X.
Yeah, I mean, the first thing I'd say is that anything that is where you have a negative and a positive, they cancel each other out, right? So a positive x will cancel out a negative x. This positive x will cancel out this negative x. And all together, what are we left with? Well, we have an x squared. What else do we have? What's left? Yep, plus just 1x. If you put a 1 in front of it, that's not wrong. And what do we have here? Negative 1, negative 2, negative 3. Very good. Minus 6. Good. Does that make sense? All right, try the next one. Whoa! Good God, man. What is the next one? Did I put x plus 1, x minus 3?
Orlando, I found another way to stare at the sun without going blind. You just need to look through these tiles.
That's true.
You literally cannot see anything.
That's true. You could have made your own eclipse glasses with that.
I feel like that wouldn't work. Like, I feel like there's just something about it that
I
probably
thought
wouldn't work.
my blind. I don't know this.
The only thing I'd worry about is if they, just because they filter visible light, the concern would be that they don't filter UV light. And then you could think that you're like blocking all that light out, but actually be blasting your retinas with UV radiation. That would be the only concern. Yeah. So there's that concern.
Okay, wait. I have a question.
Yeah.
If you're blind, you have to wear those glasses to protect your eyes.
Well,
If you're already blind, then why do you?
blind is an interesting thing. Like I went to school with a guy who was blind. Most people who are legally blind can see. They just have usually a problem with the lenses of their eyes, where like they really, really can't focus. So light comes into their eye, it does activate the retina and information is sent to the brain, but that light is so out of focus they can't see a clear image or a very clear image. And so somebody who's blind in that category, their retina could be damaged just like anybody else's by the UV light from the sun. Well, I mean, because even people who are legally blind get enough vision that it's useful.
So they're blurry, not blind.
That's right. Most people who are legally blind just have really blurry vision. But then there are people who are blind who literally have no optic nerve connection, and no, they would not be affected by staring at the sun. But they would also not see anything when staring at the sun. Right? But that's not most blind people, as I understand it. Though again, I would like to be very clear.
Because their eyes, they don't, like, they don't, normally they don't blink, right?
I don't know. I don't have a good answer to that question. I'm sorry.
Your eyes are all cloudy.
I don't know. Yes, sir.
Yeah, the Corville family, Tim is like asking that question because they do running eye to.
Oh, okay. Yeah, like I said, one of my good friends is legally blind, but in his case, he just has severe astigmatism. I mean, he can see. He, in fact, he has a YouTube channel called Blind Gamer where he does reviews of video games from the perspective of a legally blind person, which are quite interesting. I encourage a good watch. I think usually a bit more detail than that. Yes, sir. Forms for Brock trip. This is who you have or who you need?
That's what I have.
That's who you have. So you don't have Taylor Blaze, for example? Do you have a copy of the form, Taylor? Jim, do you have a copy of the form? Cool, yeah. Make sure you get these in, guys.
I just need by tomorrow, because we're on Wednesday, so tomorrow's the last day.
A, it's going to be a good day. B, I'm going to leave miserable work behind. Like miserable work behind. So make sure you come.
All right, so just remember, try to get that in. If you need a blank form, come see me before you leave.
What are we even going to do?
What would be your like 10-second description of what they're going for?
Brock, you work financial literacy. Basically, you're going there and see like post-secondary OSAP, information OSAP, could be jobs, resume writing, you should deal with money. Okay, looking for a job, looking for financial assistance for post-secondary. You can tour Brock.
And again, like even though it's at Brock, it is not geared only to university-bound students at all.
College, university, if you're just going straight out to they'll help you out with anything. And it's not only Brock. Brock is just hosting it. There's going to be all the other support groups there. You can go to groups and get it. It's we leave at around 9 o'clock in the morning. We're back by 1 o'clock, 1:10. So we're back in time for 3 or 4. If you are coming, make sure you bring a lunch or bring money. Remember, Brock does have a food court there. Your usual Tim Hortons, Subway, whatever, but it's expensive, so you can bring lunch. So see you. Okay, so gain the form, come see me. If you do have a form, please. Tomorrow's the last chance to get it in. Just bring it, just drop it off right at the main office. Right?
Sorry? I do not have any left, no.
Okay, thank you.
All right, so how would I fill this in? So I need an X square? Like that?
Yeah, and one positive line.
Okay, that goes down here, right? And then? Great, there we go. And what does that work out to? I'm going to use my snipping tool because I'm clever like that. Do you guys know about the snipping tool built into Windows? It's like the greatest thing in the world.
I find it really nice.
Your taskbar. Just swap into your taskbar to get an arrow method.
Oh, that's a great idea. You know what? I'm going to do that right now. I'm going to pin it to my taskbar. As a teacher, it's like your best friend.
I use it for business.
Now, when we go to tally these up, what cancels with what?
One of the negatives.
Like that. Good. Is there anything to cancel these negatives out? No. So I'm left with what? Negative what?
2.
Negative 2. Okay. Negative 2 what though? What are these? These are x's. Good. And x squared. Good. Well done.
So very complicated.
What is it? The oh
Did I miss something?
no.
I miss things sometimes.
No, I missed something.
Well, you're forgiven this time.
What next time?
You're fired. You're off the island. We don't have an island, but I don't think I have the power to expel anyone. In fact, I'm pretty confident. And it's a good thing. And it's a good thing too. Let me tell you, because man, would I.
I think I've lost an electron.
Sorry.
Can you suspend it?
Here's the deal. I know, but I am pretty confident if I said like so and so needs to be suspended, they would like for a good reason they would do that. No. But I don't believe in suspensions. Outside of, I think somebody should be suspended if we think like they're a danger or something like that. I think you're just giving the kid what they want.
Yeah.
Like,
I remember like I would get suspended and then I'd like go to hospital with my mom.
yeah, that sounds like a great day. I mean, it wouldn't have been great for me because I think if I'd ever been suspended, like people use the expression, but I think there's reasonable odds my mother actually would have killed me, like ended my
But like
life.
I guess it's like under different circumstances, like sometimes they'll suspend you for like the dumb stuff.
Yeah, I think my mom still would have ended my life. She's a terrifying lady, Jane.
Yeah, like I don't see the point of that. Like give them attention, don't suspend.
Like to me, when I was in high school, they had detentions. They were after school, and they would hunt you down. And I had detention every friggin' week of my life, hour and a half every Thursday. Because I was always late. Yeah. And so your third late of the year was a half-hour detention. Your fourth late of the year was an hour detention. Your fifth late was an hour and a half, and then all the ones after that were an hour and a half. And so I'd just sit there in detention room every Thursday. It was great actually for me because I got all my homework done. So it was probably I probably had a 20% higher average in high school because I had Thursday detention every single week. But I really do.
It's good or bad.
Oh no, because let me tell you, that's the other thing. Like our teachers there, like you brought something to do and you did it, or they'd find you something. They were pretty strict. My high school was very strict. No, I never got smacked, but they were strict. They had high expectations. I'm too nice. I think we're all too nice, but that's a different discussion. Okay. I'd love to. Okay, now I want to be clear that you are always welcome to use the tiles. For most of you, you'll probably choose not to, and that's okay. What I want to talk about now is how we can do this purely algebraically. All right, and this should be review, but we'll make sure that we're all on the same page. So when we have two brackets next to like this, just like we did with the tiles, to get this x squared, we really said it was x times x. And x times x gives you x squared. Come on, there we go. And then to get this negative x here, we really did x times -1, and then x times -1, and then times x times -1, and we got 3 negative x's. So, we're going to do the same thing here that we did there. We're just going to do it purely algebraically, which is to say when you have two brackets like this, everything gets multiplied by everything. Everything in the first bracket ends up multiplied by the second. You may have been taught FOIL in grade 9 or grade 10. Yeah. I don't get FOIL. It confuses me, so I don't use it. But it's the same idea. I draw arrows. This x is going to have to be multiplied by both things in the other bracket. So what's it going to be multiplied by? It's going to be multiplied by x, and it's also going to get multiplied by 3. And specifically, let's not forget that 3 is... Yeah, exactly. I just don't use the word because I don't get it. And because what if I want to do it in a different order? What if I want to do loif or lyoff or file? I think I can do it in whatever order I want. Okay. Who's going to stop me? You? You're not going to stop me. Okay. So we multiply the x by x. We also multiply the x by -3. Then we're also going to multiply the 5 by x. And we're going to multiply the 5 by -3. So everything gets multiplied by everything. You don't like just this as a math or the way I'm doing it? Or both? Okay.
Doesn't it get screwed up if you do it in a different way? Foil?
No, you do whatever you want. This is what I'm saying. And I don't like rules. No, she can call me out. Like, why can who's a math teacher tell me what order I multiply things in? You think somebody told Newton what order he was going to multiply things in? No. Well, that's its whole thing. Like, the crazy thing about math is that, like, there's this crazy relationship between the stuff we do with numbers on a page, and then if you do it long enough, you discover that it actually describes the way the entire universe works, which is pretty mind-bending. I could go on a whole day about that. You should take biology with me sometime. Except I haven't taught biology in like 6 years. But one of these days, I'm going to get to teach it again. Okay, so let's do these one at a time. X times X gives us what? What is X times X? X squared. Good. I'm using different colors just to show you where the numbers come from. You obviously do not need to do that. X times -3 would give us what? -3 X's. Yeah. What is 5 times X? Very good. And is that positive or negative? Positive. And then here we have a positive times a negative. What is 5 times 3? Yeah. Yeah, 5 times 3 is 15. And because one is positive, one is negative, when we multiply a negative by a positive, the answer is negative. Okay. And now we're almost done. There we go. The only thing I'd say is those two middle terms are talking about the same thing. This red says we have -3x, and this purple here says we have +5x. What do those come together to give us? Is it -2?
+2.
Yeah, so let's talk about why. X squared is obviously just going to stay X squared. But now, if I spend $3 and put $5 into my bank account, what's the net total of that? -3x takes $3 out of my bank account. I'd be at -3. +5 puts $5 into my bank account, and that brings me to, yeah, +2. And then -15, does it have a like term? No, it's just all by itself, so it stays. Now, there's nothing stopping you from using the algebra tiles for that, except now we're getting to some pretty big numbers, right? Like 15 of the little tiles is kind of time consuming. Don't let that stop you, though. You can use the algebra tiles to do it, but it's a little challenging. Let's do one more of these together, then you can do the bottom by yourself.
Look at that.
How would you approach this one? Someone get me started. Yeah, Tim, get me started. How am I doing this? Yeah, so now if I do x times x, what does x times x give me? Does it give me 2x squared or just x squared? Yeah, very good. Caitlin Little, what's x times 8? Very good. Very good. Evan, sir, what do I have to do next? Okay, that's all right. What are we doing? Sure, whoever. Yeah, go. -7 times x, great. And what does that give me, Mr. Fowler? Oh, yeah, and I totally didn't draw what you told me to do. There we go. -7x. And lastly, -7 times +8. And -7 times +8 is what? Negative. Whoa! Who is that ugly guy? All right. What?
Because that's how my teacher taught me.
Like this?
Yeah. It was dumb. I didn't make it.
Well, it takes a bit of practice, but the idea is that the distributive property tells us that the first term in this bracket has to get multiplied by both of those, and the last term. Lines.
Lines. Lines on a chart.
How do we do the next one?
We'll get to.
That's what I was gonna ask you. I just need help with the first one. I'm fine.
Okay. How does this collect out? If we collect like terms here, what do we get? Yep. 156. What I would do.
Do you multiply everything by 2?
Well, that too. My advice would be FOIL, leave it in a big bracket with the 2 in front, then multiply everything by 2. It'll make your life easier. There's 2 different ways to do it. That's the easier way. Sorry? Yep. Okay, guys, try these 2 practice ones. Fill it out. Let's see it.
I'm done.
Of course you are. Tim, work these out. Let's get the.
It's Christmas. You're supposed to get back.
No, let me. Since you're done, I'll show you. Well, Tim works on this because Tim's gonna get done. So we did a lab. It was actually a fun one. Where we took.
Oh,
We
are
took
there?
the copper chloride. We dissolved it in water. Copper is. So this is copper chloride. So this is copper atoms, chlorine atoms. So if you take that, dissolve it in water, you can see how blue it is. It looks like blue cool. It looks delicious. Don't drink it.
I drank it.
Then you take the tin foil and put it in.
Oh, that
Yes, ma'am.
Was there any explosion?
Not in that one. No.
No, it just bubbled.
Oh, what happened?
Why do I always get
I haven't seen it.
at this time of the day? It's 2:10. I get headaches at this time every day. I get headaches.
Tim, are you walking?
Yeah.
I'm walking too.
We
I'm
have
not
to.
walking anymore.
We have to
No,
finish
but-
my vape test because we'll put 0 in it. And I can't. So you guys.
I did talking about it.
Hold on.
I don't know, it's like some strawberry explosion or something.
Okay. Shh.
What is
So
that?
this should be x squared.
All right, John. Good to see.
He's going up like Canadian.
Okay.
Cook like Canadian.
Okay, walk me through this.
Plus
How do I start this?
You want my Canadian grammar?
what was that?
Take your note. You're gonna have to know how to do this.
Canadian raw.
Gonna have to know how to do this. You don't have to know the first page, to be honest. But if you don't know the first page, then especially you have to know how to do this.
X and I'm multiplying it by 1. Just 2x or 1.
Just 1x.
You want to go to
Yeah.
Canadian?
There you go.
Okay, whoa, guys. Shh. Okay, let's take a look at this. What 2 things do I have to multiply first? X times x, and that gives us x squared. Very good. Tim, what's next? Yeah, x times. Very good, and that gives us what? That's okay, negative. Yeah, negative 7. Yep, but negative 7 what? Negative 7. Very good. And yeah, if you do it in the other order, the order does not matter. Next, you did negative 6 times x, and that gives us what? Very good. And Taylor, what did you do last?
For what one?
For this one here.
Plus 42.
Very good. Negative 6 times negative 7.
Positive 42.
Whoa.
2 negatives make positive. 7 times 6 is 42. Yeah, you got to be careful. Now, when we collect like terms, how many x squareds do we have there? Yep, just the one. And the nice thing in this unit, since this unit's about parabolas, at this first step at least, it's always just going to be x squared. All right, now if we have -7 and -6.
16.
Really good, -13x. Right, if I spend $7, then I spend $6 more. That's -13. Yeah, you got to watch those signs. And then, does this have a like term?
That's -8 minus camera.
Okay. Does anybody have any questions about that?
No.
That feel pretty good? Sorry? It is color-coded. Well, yeah, now we've collected the like terms.
It helps him understand.
No, I'm good. Okay. Okay, what about this one? How do I approach it? Let's get doing these a little bit on the quicker side here.
X squared minus 4x plus.
X times x. Okay, well, not that
And then
quick.
X times
X times x is x squared.
X times negative
X times -4 is.
4x, negative 4x.
3 times x is.
Negative 3x. No, positive
3x.
Yeah. And 3 times -4 is. -12. Okay.
X squared minus.
And if we collect like terms here, what do we get? Tim, give me your phone. Okay. Yeah, x squared for sure. Yeah, -4 and +3 is -1x minus 12. If you just put -x, by the way, that's just as correct. In fact, it's probably a little better. But my instinct towards -1 is to put -1. Both are correct. Yeah, which is not wrong, but it's clunky, right? But it's not wrong. Like, that's mathematically just as correct. It's just clunky. Okay. Does anyone have any questions about these?
No, sir.
All right. Next thing is the last little bit. Last thing we have to learn. Okay. This may be new, so I'd ask that you pay attention.
Please listen and be quiet.
Yeah, quiet down. Okay. So with a case like this, there are two ways to approach it. And I'm going to show you both. And then I'm only ever going to do it one way again. I have a clear preference, but I will show you both of them. Obviously, what makes this question different than the previous question? It's got a number in front. Okay. My advice would be this. My advice is to leave the number in front and open a bracket and just do the distributive property here first. I think that's the better method. I think you're less likely to make a mistake if we do this. So we just put the number in front and then we multiply this. X times x would be x squared. Very good. X times 4 would be very good. And -3 times x would be minus 3x. And the last term, of course, -3 times 4 is -12. Now, in my next line, I'm still just going to keep that 2 in front. And what do I do in the bracket? Eventually, but first, just like last time, what can I do with this? I have 4 x's and -3 x's. Altogether, what's that? Mom gives me $4. I spend 3 of it. How much money do I have left? $1. So I would have x squared plus x minus 12. Yeah, it's a trick question, right? And now that 2 is in front, and don't forget, the distributive property tells me I have to do what with that number? This 2 is going to be multiplied by all the numbers. So 2 by x squared is what? 2x squared.
Plus 8.
And I'm going to stick with colors here just to be really specific. 2 times x is?
Oh.
2 times x is? Very good. And lastly, I need another color. Gray it is. And 2 times negative 12 is negative 24. Okay. And that would be the final answer there. So that is my advice on how to solve this question. But there's another method, and it works, but you have to know something about the rules of multiplication. Which is, if I want to distribute the 2 first, that's fine, but I need to remember that I only do it to the first bracket because it will inevitably get distributed into the second bracket when we do bracket times bracket. So if you're going to multiply first, you only multiply it by the bracket it is directly touching. I think that's more confusing. I think it's more likely to lead to you screwing up. It's not how I recommend doing it, but I want to go through and look at just this example, okay? Again, this would not be my recommendation, but what's 2 times x? No, 2 times x is just 2x. What's 2 times negative 3? Negative 6. And we close that bracket, and the next bracket is unchanged. And now we can do this distribution. What is 2x times x? Well, 2 times no number just stays 2. X times x is x squared. Good. What is 2x times 4? 2 times 4 is 8, but we still have the x. Okay. Then what is negative 6 times x? Negative 6x. And what is, I need a color. There we are. What is negative 6 times 4? 6 times 4 is? And that would be negative. And now I could collect like terms. 2x squared. What is 8x minus 6x? 8x minus 6x is? Very good. And minus 24. These are both okay ways to answer that. In my mind, this makes more sense.
I have a question.
Yeah.
Where would you use this type of stuff in real life?
Nowhere.
No, you listen. Shh. No. It's a good question. It's fair. For a lot of math, the answer is never. A lot of math is beautiful for its own sake. This comes up quite a bit. This comes up a lot in financial math. It would come up a lot if you did design and architecture. It would come up a ton, like a ton, if you got into coding, into computer programming. But even coding on the scale of like website design or graphic design, it would come up a lot. It would come up if you studied like any,
If you were a math teacher.
well, obviously, yeah. If you study math, in science, it comes up all the time. So you'll do this kind of math. Like if you take grade 12 chemistry with me, we solve a lot of quadratics because a lot of chemical reactions follow rules defined by quadratics. It comes up a lot in physics. And it comes up a lot in finance. Now, having said that, in 2017, we mostly make computers do this for us, right? Like that's the reality. In most jobs, are you sitting doing this by hand? No. But like for sure coding. Like if you got into coding, or if you got into physics or any hard science, you'd do these like crazy. It's a compliment, I'm sure. Okay, let's try one more together, and then you can try a couple without me. Again, my advice is to leave this number in front until you get to the end. Not the only way to do it, but as far as I'm concerned, the better way to do it. John, do you have this one done?
I have all of them.
Great. Can you tell me how you did this one? The sound of disgust in John's voice was palpable. Ugh, Orlando, you're boring me. You're wasting my time.
Is that right?
All right. Okay, so x squared. Okay. Very good. Whoa, that wasn't the color I wanted. Okay. Now, when we collect like terms, what do we get here? I like this one. Christopher, what'd you get? No, no problem. Well, let's do it together. That's okay. How many x squareds are there in this line? X squareds? I just see this one, right? So x squared. But now let's take a look here. Plus 1x minus 1x. Chris, if I give you $1, what am I immediately going to then do? No, I'm going to take your $1. I'm going to say, here's $1, and then I'm going to be like, oh, that's my $1. If I give you $1 plus 1x, and then I take $1 away immediately, how much do you have? You have $0. That's correct. And then minus 1, right? Is that comfortable for everyone?
Yeah. I just didn't put in that 0x.
Yeah, you do not have to put in the 0x. In fact, I would write it like that. Now, what's the last step then? Yeah, so we multiply 4 by x squared to give us 4x squared. Very good. And we do 4 times -1, which gives us -4. And that would be the final answer. That make sense? Okay. I want you to finish these 2 examples. And then for homework, I know we haven't done the last page yet. You will note that I cleverly planned for that by nothing from the last page being in the homework.
Wow.
I know, look at me, right? Make sure you get that homework done. I know, right? I feel like such a big kid. Don't worry, tomorrow I'll make some horrible mistake to make up for it.
Oh, that chemistry test is
You're gonna do great. Or you won't. It's hard.